Hello and welcome. In this lecture, we will discuss how to handle exceptions in a Spring MVC application, introduce exception handling in our application, do a bit of code cleanup so as to remove some hard coding. We will create a new feature branch named cleanup. First, we will ensure that we are on the develop branch with the git command git checkout develop. Then, we can create a new feature branch with the git commands git checkout -b cleanup, git push -u origin cleanup. We will start by making a few changes to the Stripe exception that we have created in the previous lecture. We can head back to the Stripe service class, and where it catches exceptions and then throws Stripe exceptions, we add the code exception to the Stripe exception constructor. This will not compile because first we need to create a constructor in the Stripe exception that accepts an exception. Luckily, IntelliJ can do this for us. All we have to do is ask. We can click on the red bulb and ask to create a constructor. Then we need to select throwable as argument. That's it for Stripe. Now we will do something similar for the S3 service. We will first create an S3 exception under the exceptions package. The class will extend runtime exception. Then we will declare a constructor that accepts a throwable as argument and delegates to the parent class the exception instantiation. Now we can head back to the S3 service class and make few amendments. First, we will remove the throws IO exception clause from the store profile image method and replace it with a try catch statement that catches an IO exception and throws the S3 exception that we have just created. We will also update the Java docs to reflect this new contract. Then we will throw an S3 exception from the ensure bucket exists and store profile image to S3 methods when an Amazon exception occurs. Now, we are ready for handling exceptions when things go wrong during the subscription journey. We will create a new HTML page to display when an error occurs. First, we create a new error folder under the templates folder. We can copy the change password HTML page from the forgot my password folder, removing all container content. I'm now going to copy the code that I've prepared for this lecture, and then I'll talk you through it. This is a generic error page, therefore we display a short and user-friendly message in a Bootstrap Jumbotron. Then the page checks if the objects URL and timestamp have been set in the model, and if they have, it displays their content. What follows is a timelift trick to display the exception technical details when users view the page source. This is because we don't want to display technical messages and stack traces to users. However, the support team, while investigating an issue, might ask users to send them the content of the page source. Please pause the video and make sure that your page looks like mine. You can also refer to my code on GitHub. Now that we have a generic error page, we can head back to the signup controller and add exception handling. There are various ways to handle exceptions in a Spring MVC application. Using HTTP status codes via the response status annotation, controller-based exception handling via the exception handler annotation, and finally, global exception handling via the @controller_advice annotation. There isn't a right or wrong way of doing it. Personally, my approach is the following. If a particular set of exceptions is specific to a journey managed in a single controller, I tend to use controller-based exception handling. If an exception might occur across several journeys and controllers, I use a controller advice. In our case, since both S3 and Stripe are particular to the user sign-up journey, we will be using controller-based exception handling. First, we open the SunUp controller and add a new method called SunUpException. The method accepts an HTTP servlet request object and an exception object the Spring will automatically set for us. The method returns a model and view type. This is a new type that we haven't discussed yet, but it's simple to understand. It's a combination of a model map and a view name, both being concepts that we have already learned. We annotate the method with the exception handler annotation, to which we pass an array of exception classes, containing the Stripe exception and the S3 exception. I'm now going to copy this method implementation from the code that I've prepared for this lecture, and then I'll talk you through it. The first thing we do is to log the error coming from the exception. The method then creates a model and view object and sets in the model map the objects expected by the generic error page that we have created a few moments ago. It then sets the view name to be the name of the generic error view name constant, which we haven't created yet. We can now create this constant and assign to it the value error/generic error. By now, you should know by heart that this resolves to the generic error.html page under the folder error. Now we can test that the exception handling works. We can open the Stripe properties file, copy the existing private key property, prefix the original value with the hash so that it's not loaded at runtime, and change the value of the copied one to something that doesn't exist. If we then go through the pro subscription journey, we should be directed to the generic error HTML page. I suggest to use a browser other than Chrome to perform this particular test. Chrome has a well-known issue that disables to resubmit post requests twice. This will result in the browser failing when you try to view the page source. On Safari and other browsers this works well. Now we can right-click and choose to see the source. Looking at the source now, we should see the embedded exception stack trace. Great work! If you want, you can test the S3 service exception as well. Following a similar approach, you can change the private key value for the profile you are using in the user home folder .aws credentials file to something that doesn't exist. I suggest copying the existing value first and prefixing it with a hash. You might also want to re-enable the original Stripe private key so that you're sure to test only the S3 failure scenario. If you now go through the user subscription scenario, making sure that you choose an image to upload, you should be able to see that in the page source, the application displays the embedded exception stack trace. We are nearly done. The last thing I wanted to address is a minor change to the Stripe integration test. Currently, we are using hard-coded map key names when setting the car parameters map. I like to replace these with the values we have set in the Stripe utils class, so I'm quickly going to replace these 5 lines in the test. To confirm that everything is still working, we should just run the tests again, making sure they are green. As an exercise, I'd like you to think of the journeys we have implemented so far and handled exceptions at the controller level. If something goes wrong, how can we intercept an exception and be redirected to the generic error page? We can now close the Git flow workflow by first pushing the local code remotely with the git commands git add *, git commit -m implemented exception handling for the subscription journey, and git push. Then we can merge to develop with the git commands git checkout develop, git merge cleanup, and finally git push. In the next lecture, we will be setting up MySQL locally and run against MySQL when running with the prod profile. As part of this journey, we will need to create a SQL statement to execute a startup to create the database structure. This is a necessary step in preparation for our deployment to Amazon Web Services, where we will be using MySQL on Amazon RDS. Thank you for your time, and I see you in the next lecture.